Good afternoon. Today is Monday, April the 6th, 2020. My name is Mr. Chen. In today's video series, we're going to be looking at remote learning at North Toronto, here for my classes. I'm teaching grade 9 math, academic, and enriched. And really, hopefully, you're doing well, healthy, and hope you're okay. I apologize for rambling a little bit. It's been a long day. Please feel free to pause the video if I'm going too fast. And this video series is just going to be a recap of what you've already kind of learned in the linear units. We're basically going to be looking at linear equations, linear relations, and investigating how those tie in. You already have hopefully looked at the Google Classroom, and you have actually hopefully looked at some resources sponsored by the CEMC, which is from the University of Waterloo. Also, if you want to follow along with today's video, hopefully you've downloaded the worksheet that accompanies it. Let me just quickly share the screen to show you what we're talking about. So as you can see from the screen, we have my email, nt.rchen@gmail.com, or you can email me at raymond.chen@tdsb.on.ca. These two emails, you're more than welcome to inquire or leave messages if you're having some trouble with the lessons or some of the work, or even anything that you're dealing with, the anxieties at school or your online learning here. I understand you're going through a rough time. Rest assured, today, feel free to pause the video, skip this video entirely, and I just want to highlight today that we're going to be looking at slope, equation of lines, standard form, and first difference. Let me switch to tablet mode really quickly so I can write easier. Just bear with me for a moment. And really quickly, as a refresher, what is slope? Slope of a line is written as the rise over the run. We also know it as a formula. If we have 2 points, we take the differences of the y-coordinates and divide it by the differences of the x-coordinates, or y2 minus y1 over x2 minus x1. Now we actually want to talk about the second part of the lesson. We're going to talk about equations of lines, and it's going to talk about standard form. Standard form of a line is like a formal way of expressing what the line looks like, where a and b and c must be integers, a must be positive, and it must be equal to 0. Whereas a lot of students in grade 9 actually like the format of y equals mx+b, where we call it as the slope y-intercept form. Finally, as a refresher, the first differences are simply looking at the changes of the y values and seeing if the pattern of the data is actually a linear one. If they're all the same, we know that it's a linear pattern. If they're not the same, then we can say the pattern is nonlinear. Let's take a look at the worksheet now. Hopefully you have this sheet, and I'm just going to walk through it. The very first question says, find the slope of the line and provide one comment about the slope of that line. Hopefully you're doing it with me. Let me just zoom in really quickly so you can see a bit better. We have a point A, 2, 3, and B, -5, 2. Find its slope, really easy. I think you guys actually understand. Point A could be our first point, and point B could be our second point. Notice we always go first, x, y. So in this example, I'm going to do 2 minus 3, all divided by -5 minus 2. We get our answer of -1 over -7. But a lot of you realize that this fraction can actually be reduced to positive 1/7. Now we have to comment about this line. This line happens to be a rising line. It's a shallow line, but nonetheless it is rising. It rises 1 unit and runs 7 units. With question B, we're going to do it the other way around, just to show you it does not matter which point we choose to be the first point. In this example, we're going to make -3 our second point, -2. And whoops, I meant to say it. Let's just erase that again. My apologies. I meant to say make 2 minus -3 and -11 minus 8. And what do we get? 2 minus -3 is 5. -11 minus 8 is -19. This slope of the line is a negative line, so we can actually deduce that this line is going to be a falling line, as it has a negative slope. Our second question talks about equations of lines in standard form and slope y-intercept form. For question 2a, we have a point and its slope. So really easy. If you had me, or you're just joining us, we actually have a form called point slope equation that I like using. It's actually derived from the slope equation, but relatively easy. We sub it into the equation. Y minus -2 is equal to -1 times x minus 4. And to put things in standard form, we actually have to probably clear the brackets. So there's a couple ways of actually going, and you might actually get a different way, but that's okay. We get -x plus 4. And again, how did I get plus 4? -1 times -4 is positive 4. Now to put things in standard form, a lot of you might think that you just have to put it any way you want, but I think everyone agrees we must make sure that the a value is positive and they're integers, they must be equal to 0. So in this example, we're going to put the right-hand side to the left-hand side by adding x and subtracting 4. And what we get is x plus 4 minus 2 equals 0. This is the standard form of the equation of that line. If I wanted to put it in slope y-intercept form, we can actually go from this line, and let's just draw a line so it separates it so we can follow along. And notice that helper formula, that point slope equation, helps us also go into y equals mx+b. So what we can do is subtract 2 to both sides from that line, and what do we get? We get y equals -x plus 2. This is the equation in slope y-intercept form. Notice for question B, this slope is 0, and we should be suspicious about this. A slope of 0 means that this line is probably horizontal. So although we could actually use the helper formula, or we can use the y equals mx+b equation, you know what? It's actually easier to understand that this line will have all the same y-intercepts. What does that really mean? The equation of this line is going to be y equals -5. And this is the equation in slope y-intercept form. In standard form, all we have to do is add 5 to both sides, and we get y equals plus 5 equals 0. So that's the equation. So I decided to do these two a little differently. One more time if you need some help. This equation is y equals mx+b, and this one is standard form. Let's keep on going. Question 3. Write an equation that passes through the points 3, 1 and 9, -2. Notice, I think a lot of you realize we actually have to find the slope of this line. So -2 minus 1 all over 9 minus 3. We get in the numerator -3, and we get in the denominator 6. We actually realize we have to reduce this fraction, so we get -1/2. Using that helper formula again. And it didn't specify in this question, so we're going to have to do both of them just to make sure you're okay. And if it doesn't specify, you actually have two choices, standard form or y equals mx+b. I'm actually going to first show you the standard form. And hopefully you're following along. You're realizing where I'm getting these numbers. I'm using that first point, 3, 1. And it should not matter. It should not matter. But just for time's sake, I am going to use that first point, 3, 1, as my point. And let's put this in standard form. Now, we actually probably can do a couple things, right? We can get rid of the fraction, or we can make it equal to 0. I like getting rid of the fraction, and that fraction means there are those two fractions there are divided by 2. So the opposite of divide by 2 is multiplying by 2. So there we have it. But we're so close. And I think you're okay. Did I make a mistake? I am checking my work really quickly. Nope, seems all right. I think I might have made a mistake. For some reason, I can't see it. No, I'm fine. I'm going to add x, and I'm going to subtract it to both sides. I'm sorry. It's been a long day. For some reason, I was getting a little nervous. Let's keep on going. From this equation here, putting it into the y equals mx plus b. I'm just going to copy it again so that everyone's okay. I'm going to add 1 to both sides. I'm going to show my work actually for this one, though, just to make sure everyone's okay. Adding 1 means 2 over 2. And why am I doing that? Well, with fraction, we have to get a common denominator. So there you have it, ladies and gentlemen. We have 2 equations. One is in y equals mx plus b. The other one is in standard form. Let's move on. In this question, we have a line that's given to us, and we need to find the slope of that, slope y to the form of the line. Also, by inspection, it's a falling line, and so chances are you actually understand that this slope should be negative. More importantly, notice at this point here in purple that I'm pointing, that point is 0, 4, which is the y-intercept. And this point here is the x-intercept. So in some descriptors, you can actually think of that this point, if you were to describe it to somebody in transformation, it seems to be going down 4 units. And it seems to be going towards the right 6 units. So this is more of an understanding what slope really is. Since slope is rise over run, you can actually say the slope is, well, the rise in this case, it's not a rise, it's actually a fall of minus 4 units. And it seems to be a run of positive 6. But again, we reduce this fraction, and if you're paying attention, that slope of this line should be negative. So we have negative 2 over 3. Now we just to put it all together. What is the y-intercept? I already said it. The y-intercept is 4. 0, 4. So y equals mx plus b. Really easy. Y equals negative 2/3 x plus 4. We didn't really have to do any equation. We just had to do some problem solving. Question 5 is more interpretation. What's it saying? What are the differences of a vertical line and a horizontal line? A vertical line has a slope that's undefined, whereas a horizontal line has a slope of 0. Specifically, just to help some people out, and let's just draw a sketch of a Cartesian plane. Let's just say we had this vertical line. And if we had some points on this vertical line, all the x coordinates are equal. In this example, we could have maybe y, keep on doing that. Why is that a problem? X equals 3. So that's a vertical line. How about for a horizontal line? So maybe we have this horizontal line that goes up here, and we have all those points. And notice all the y coordinates are the same. So in this example, it could be maybe y equals 7. They all have the same y coordinates of 7. So it's just like an interpretation. Finally, we have the first differences. And what are the first differences? Really, really quickly, you know this as the changes in y. Of course, you have to still check the interval of the x values, the independent variable. And if they're going all the same, then we can only do our analysis. But with first differences or finite differences, we always have to go in this pattern. What is that pattern? Notice, we're going to do the 3 minus 7. 3 minus 7 is negative 4. Now, what's the next first difference? I think everyone agrees. We're going to take that negative 1 and minus 3. And some of you are slowly seeing a pattern of actually the method of actually solving this. Notice, be careful here, negative 5 minus negative 1 is negative 4. But look at this answer, negative 7 minus negative 5, which is negative 2. So what can we deduce from this? the data is nonlinear. And why do I say that? It's because the first differences are not all the same. So this is a conclusion of what we've been talking about in grade 9 math. Just a little bit to get everyone used to and back on track of things. One more time, you have your resources of your handouts that I've given you. You have your textbook, your Nelson textbook. You have the Google Classroom, and you have the CEMC. And finally, you can always email me if you're having any troubles. I wish you the best of luck, and hopefully I look forward to seeing you actually in a classroom setting. Have a nice day.